session, session 7, is Mixed Reality Robot for Teaching Programming. And this will be presented by Oka Kuniawan and his team. Oka is a senior lecturer in the Information Systems Technology and Design. He has been leading the largest introductory programming course at SUTD for the year 2015 till present. He is a 2018 SUTD Teaching Excellence Award winner and an AHE Fellow. In this presentation, Oka's team will be doing a demo of their ongoing mixed reality robot project for teaching programming. The floor is yours, Oka and your team. Thank you.
Thank you, Joel. So it's great that I can present here this study with you. So we have not really completed the study, but I think we're quite excited to share with you. So Norman is my colleague. He's also the PI for this, the investigator for this project, and also Nacha is actually advising us for like the education study aspects on how to conduct the study. All right, so let me share with you. So actually we begin this study quite some time. So we found this paper in 2011 talking about robots. So we've been using robot in teaching programming. I started very early in SUTD, and we realized that the literature speaks a lot how actually using robot motivates students. Right, and so there's one literature review talking about how's the states and on the impact on students. And what is interesting is that at the end of this paper, actually, there's a lack of study on comparisons between a simulated robot or a simulations as compared to a physical robot. So some studies, they just do the physical robot, some studies, they just do the simulation robot. Some study do both, but at the end of the paper, actually, they realized that there's not much study on the simulated robot and how effective that is as compared, for example, to a physical robot. So actually, we took up these questions in our study. So we realized that, and from our own experience and from the literatures, like using robot is actually more interesting, and students can actually see it applied in their real life. It's very tangible. And because of our computing course, it's actually for the first year, and it for various background, right? So actually there's some paper that mention why using robot actually beneficial for students because they actually provide multiple learning paths. Some may be just interested with, seeing the robot moving. Some may be more interested in the tangible aspect, on the hardware. Some are interested more on the sound and the lights. So there are many people can find different point of interesting things when they are using the robot. And that's why actually we use it also in SUTD. But there's also some disadvantage when you're using the robot. One is actually the cost and the logistics. You have to keep the robot, and when you use the robot, there can be like hardware failures. And so you have to replace the robots every year or after every semesters. And when you do programming with robots, when things are not working, they may not know whether is it a hardware failure or is it my code, especially for novice beginners, right, novice programmers. So it hinders certain learning in that sense. So we did a study a few years ago, I think in 2018, and we actually compared a physical robot with a simulator, and we purposely make the simulator to be plain because we want to study effectiveness in terms of the learning gain as well as on the interest, the confidence level when they are using these two kinds of robot. So we published that paper in IEEE conference, and what we found interesting is actually in terms of the learning gain. So on the top right here, we actually do like some pre and post tests. Even though there's some differences, but we use some statistical analysis to show that actually in terms of learning gain, there is no significant difference in terms of the learning gain. So that means you don't have to use a physical robot, right? So you can just use a plain simulation with just like lines and moving around. So the one on the right is actually from Turtle Python. It's already built in Python, but we make the interface to be similar to our physical robot, so that it's exactly the same command. So we wrap the libraries actually using our own library. So in terms of the learning gain, there's no significant difference between the two groups. However, when we look into the interests and in terms of the motivations, whether they want to pursue computer science in the future, actually there is the one that use physical robot has more positive results, right? So I think just now Keegan also mentioned in his presentation, students are more excited with new technologies or these kind of things like the VR. So we found that so like if you look on the bottom right, those who are using the physical robot, they participate more, they feel more engaged, they're more interested in learning programming, in taking computer science. So we still found reasons to use physical robot in our educations in SUTD, and that's why we're still doing it until now. At the same time, we look into the comments and on the feedbacks, and we found that those who are using physical robot has more negative comments. So that's quite interesting in the sense like even with those negative comments dealing with the hardware and all this kind of stuff, they are still more interested in computing or in learning programming. But we realize that there is this more negative comments when you're using hardware as compared to just pure software, right? So this is our next study basically that we are going to do. Can we have the best of these two worlds? I mean, like, can we have the one that make students are interested more with the tangible aspects of the robot, but at the same time, we don't have so much the hardware issues that the physical robot would have, right? So that's where we look into the mixed reality, augmented reality project. And this is actually our first prototype. And we actually rule out the virtual reality technology because it's what we want the students to do is actually to write Python code. Um, and it's just really difficult to write or to type in a virtual reality settings. So we are looking into mixed reality or augmented reality technology to do that. So let me share with you this video. This is just our first prototype. Some of you may have seen it. And then I'm going to show you the second prototype we are developing. Yeah, so as you can see that, so as you can see that student can still write their own Python code and then they can, but there is no such physical robot that they have to deal with, right? So they use, it's called the Meta Vision. So that costs like about 2,000 to 3,000 Singapore dollar just for that one goggle or headset, and it has a cable that must be connected to the computer. Right? So another alternative device actually you can use Microsoft HoloLens, but it's even more expensive, like about 4,000 to 5,000 dollar. So it's very difficult to bring it to the class, right? So what we are trying to do is that in the second prototype, we take some of the feedback and some of the issues. There's not much interaction, for example, with the objects. So, and then the cost also is quite high. So we realized that we can actually implement it using iPad. So iPad Pro now has a LiDAR sensor, for example, where you can mesh physical objects and it can be part of the AR kit where you can interact with. So when we develop our second prototype here, we decided to use iPad instead. So this is like a kind of setup that you will see. This is actually my dining table there. So you have markers around that defines the boundary of the robot. And then there's the iPad where students can type on the keyboard, and then they can actually see the simulated robot. And they can actually change the boundaries. They can change the objects on the floor. They can actually move where the robot is starting, all this kind of stuff. I think I have a photo for that. So this is a setup, basically what the students will do. So first, like they have to detect the flat surface where the robot are going to move around, and then they need to detect the wall markers. That's basically defining the boundaries where the robot are going to work on, and then they can place the marker for the robots where the robot can start at what orientations or at what locations, and then they will start to write the code, and then they will test it immediately. So if you see on the right there, so actually the students are writing the code, and then they are seeing the simulated robot actually, and they can immediately test, right? So there's also speed in terms of seeing the results. And this is actually the video that we took for the second prototype. So let me show it to you. So that's mainly the things that we have developed. So we are developing it now, and in fact, we are actually starting to inviting the participants to participate. So we have a few students this morning. So I just came back from that, and I'm very tempted to share with you the result, but I think it's better to when we have more data to share with it. So this is the study plan that we're going to do with the participants. So some students will start with the physical robot. Another student will start with the mixed reality, then we're going to have some survey where they will assess their experience in using the technology. And then after that, they will do the other technology, then they have another survey. And then on the third task, which is optional, they can choose which technology that they want to use to do that task, right? So we're quite excited to know what's the, when we have more data, and hopefully we can share with you more. I think something that we are also interested is actually how tangible the thing should be when it starts to excite students to learning. So we are looking into the boundaries of between something that's really real that create excitement. So there's some paper that shows that tangible object actually helps people in learning when they can touch or can feel. And we are actually want to check where is that boundary with this technology mixed reality technology. All right. So that's basically the end of my presentations. And if you have any questions, please feel free to ask your questions.
Hi, everyone. If you have any questions, you can type them down or unmute your mic for Oka. Okay, we have a little bit of time. So if no questions, maybe we can have an early break and be back at 4:40. Yep. In the meantime, if you have any questions for any of the presenters, you may unmute your mic and maybe address the speakers to address your questions now from the previous sessions. Thank you.